Okay, so we've done a lot of examples of comparing our rational expressions and rational numbers. So I just wanted to give you sort of an exemplar of how you can do that, especially when it comes time to do it on something like an assessment. So we're adding two rational expressions. It can often be equivalent to exactly how we would add two rational numbers. Now, you might have to think about adding your rational numbers in a different way than you're used to in order to show that these two processes are the same. So the first thing we like to do with our rational expressions is to set them up in vertically. Also in this step, I'm just going to do my factoring when I go to write it down, just so that it's already done. So I have x minus 2x plus 3. So maybe you've already noticed that in my second fraction, these two, right here, we have a factor in common. So even though they currently don't have a common denominator, x minus 8 and x plus 2 plus x minus 6, we don't necessarily have to multiply the whole denominator by the whole denominator, because we can simplify the second fraction first. That's similar to our number problem over here. So if we take 14 over 6, that's equal to 2 times 7 over 2 times 3. And we can, before we do any more of the problem, instead of having to multiply 7 times 6 to get a common denominator, we can simplify. We can make 1 here, and then we only have to multiply 7 times 3 to get a common denominator. And that's going to make the problem just a little bit easier. It's going to get a little less wonky just in the number of things we have to work with. So same as the process over here, x minus 2 over x minus 2 makes a giant 1. And when we do that, we simplify our problem before we start, and then we do not have to worry so much about having 3 factors in the denominator. We only have to worry about having 2 factors in the denominator. So now let's make our common denominator. We're going to multiply this one by this factor, x plus 3, since that factor is missing from our first term. And we're going to multiply this term by x minus 8, since that factor is missing from this term. And since we simplified before we started, we don't have to worry about that extra factor of x minus 2. Similarly, in our number problem, we would multiply 3/7 by 3 over 3. This 3 coming from the denominator over here, so we get a common denominator of 21. We're going to multiply this fraction by 7 over 7. So again, we get a common denominator of 21. Since we simplified first, we don't have to worry about a 6 and getting a denominator of 42. We can just work with 21, which is just going to make all of our problem solving a little bit easier because the numbers will be a little bit smaller. The next step in both of these problems is that we multiply so that we can then do our addition. So when we multiply here, we multiply 5 times x plus 3, and we get 5x plus 15. In these rational expression problems, I like to leave the denominator factored so that if I try to simplify at the end, it's already in factored form. And then we do 7 times x minus 8, which is 7 minus 7x minus 56 over, again, the common denominator now, x plus 3, x minus 8. That's exactly the same steps that we would do in our fraction problem, which is we would multiply straight across, get 9 over 21, and we would multiply straight across and get 49 over 21. So now the last step is the same again for both problems, and that's that we add the numerators and we keep the denominators the same. So when we add the numerators in our algebra problem, we actually have to add we're going to combine the like terms as we do it. So 7x plus 5x is going to give us 12x. Check my math here. And let me grab a calculator. 15 minus 56 is going to give me minus 41 over x plus 3, x minus 8. On this side, I'm going to add 9 plus 49 and get 58 over 21. The last thing that these two problems have in common is that neither of them can be simplified. So 12x minus 41 cannot be factored. So we're going to just leave it there as 12x minus 41. 58 over 21 also cannot be simplified. The factors of 21 are 3 and 7, and 58 is not divisible by 3 or 7. thing that does make these problems different is that 58 over 21 is 100% the answer 100% of the time. There's no other possibilities. This is, of course, the answer all the time, except it won't work if x were to be 2, -3, or 8, because if you were to plug any of those numbers in, this expression would be undefined. So this kind of works all the time, although it only gives us one value. This is going to give us lots of different values for lots of different x's, but we can't use just these 3 specific values of x.